Question number 25. The percentage of hydrolysis of 0.003 molar aqueous solution of NaOCN is K of HOCN is given as 3.33 into 10 raised to minus 4. Let's try to find out. This is based on salt hydrolysis. The salt is NaOCN. So OCN minus reacts with water. This is a conjugate of a weak acid, so it's a strong base. It reacts with water and OH minus. This is the reaction which takes place. So you can put it as C into 1 minus alpha, where alpha is the degree of hydrolysis. This is C alpha, this is C alpha. So you get KH equals to C alpha square. And we know that KH equals to KW by KA. So alpha equals to root over KW by KAC. This is the formula we are going to make use of to find out alpha. Alpha is degree of dissociation. Let's try to put the values. KW is 10 raised to minus 14, and then this is 3.33 into 10 raised to minus 4, and this is 3 into 10 raised to minus 3. If you put all these values and calculate, you get alpha equals to 10 raised to minus 4. This is degree of dissociation. So percentage is 10 raised to minus 2. So the correct answer is third option. Question number 26. The characteristics which do not represent chemical equilibrium are: A. Delta G equals to 0. This is true for equilibrium. At equilibrium, delta G is equal to 0 because the rate of forward reaction becomes equal to rate of backward reaction. Both are equally spontaneous. Option B, the properties of the system are time dependent. This is not true. You know, the properties do not change with time. Properties, once the equilibrium is established, the properties of the system do not change with time. Option C, the rates of forward and backward reaction are equal. This is true. At equilibrium, rate of forward reaction becomes equal to rate of backward reaction. Option D, the concentrations of reactants and products are equal always. This is not true. When equilibrium is established, it is the rate of forward reaction which becomes equal to rate of backward reaction. It is not necessary that their concentrations become equal. Concentrations of reactants and products may or may not be same, but rate of forward reaction will always become equal to rate of backward reaction. So the correct answer is first option. B and D, these two statements are do not represent equilibrium, chemical equilibrium. So the answer is first option. Question number 27. According to Chatellier's principle, at equilibrium, which of the following is not correct? Option A, if QC is greater than KC, the reaction proceeds in the forward direction. Option B, addition of reactants and removal of products makes the reaction to proceed in the forward direction. Option C, in exothermic process, low temperature is favorable for forward reaction. Option D, if the pressure is increased, the reaction proceeds in the direction in which the number of moles increase. The correct answer for this is option 2, that is statement A and D are not correct. You can see statement A, if QC is greater than KC, the reaction proceeds in the forward direction. This is not true. When QC, reaction coefficient, becomes greater than KC, it is the backward reaction which takes place. And option D, you see, if the pressure is increased, the reaction proceeds in the direction in which volume decreases. That means the reaction will proceed in the direction where number of moles decrease. So option A and D are incorrect statements. So the correct answer is second option. Question number 28. Which of the following will form a buffer solution? You know, buffer solution, you have two types of buffer solutions: mixed buffer and simple buffer. We are having 4 options of mixtures, so we'll consider mixed buffer. So mixed buffer is a mixture of weak acid and its salt, or it may be a mixture of weak base and its salt. If you look at the option A, sodium acetate is a salt and acetic acid is a weak acid. So mixture of these two acts as a buffer. It is acidic buffer. And then B is not a buffer because it is a salt and a strong base. C is a buffer because it is a salt and a weak base. And D is not a buffer because it is a salt and strong acid. So A and C are buffer solutions. A is acidic buffer and B is basic buffer. Acidic buffer is a mixture of weak acid and its salt. Basic buffer is a mixture of weak base and its salt. So the correct answer is third option. A and C are the examples of buffer solutions. While A is acidic buffer, B is basic buffer. Question number 29. In respect of acidic strengths, which of the following relationships are correct? Before I read the options, I would like to tell you that there are two types of acids, hydrocid and oxyacid. In case of hydroacids, as the bond strength increases, acidic strength decreases. So in hydroacids, acidic strength is inversely proportional to bond strength. Greater the bond strength, lesser the acidic strength. And then in oxyacids, acidic strength is proportional to oxidation state of central atom. So if you apply this, see, in the option A and option B, we have hydroacids. So H2TE is a stronger acid than H2O because of weaker bond in H2TE, and H2O is weaker than H2S because H2S has a weaker bond. So A and B are incorrect. Look at C. C is H2SO3 and greater than H2SeO3. This is true. You know, acidic strength also depends on electronegativity of central atom. So H2SO3 is more acidic than H2SeO3 because sulfur is more electronegative than selenium. And similarly, look at option D. HClO is a weaker acid than HClO2 because see, in HClO oxidation state of chlorine is +1, in HClO2 it is +3. So this is stronger than this. So the correct answer is second option. C and D are correct. A and B are incorrect because water is a weaker acid due to stronger OH bond than OS bond or OT bond. Question number 30. When calcium carbonate is heated in a closed vessel at a definite temperature, the pressure of carbon dioxide formed remains constant irrespective of the amount of calcium carbonate taken. So if you increase the amount of calcium carbonate, that is not going to affect the pressure of carbon dioxide. That's the meaning of the statement. See, you are heating CaCO3. This is a reversible process. CaO plus CO2. This is a solid, this is a solid, this is a gas. Now you are heating it in a closed vessel. So any increase in the amount of CaCO3 will not increase the pressure due to carbon dioxide. The pressure due to carbon dioxide is independent of the amount of calcium carbonate because this is a solid, its activity is always taken as 1. Now I'll read out the reason. The concentration of pure solid remains constant in the reaction and it is always taken as unity. This is a correct statement. So, and it is a correct explanation for the first statement. Any increase in the amount of CaCO3 will not increase the pressure of CO2 because CaCO3 is a solid, its activity is always taken as unity. So the correct answer is first option. Question number 31. For the reaction A gas plus B gas gives C gas plus D gas. See, this is the reaction which is given. A plus B gives rise to C plus D. All the substances which are undergoing the reaction, all are gaseous substances. Right. At a given temperature, there will be no effect of addition of inert gas either at constant pressure or constant volume. Whether you do the reaction at constant pressure or constant volume, there is no effect of inert gas on the position of equilibrium. There is no effect of inert gas on this reaction. Try to realize that for this reaction, delta N is equal to 0. So for any reaction where delta N is equal to 0, there won't be any effect of inert gas whether the reaction is carried out at constant volume or constant pressure. Same is mentioned in the reason. For the reaction where delta N is 0, there is no effect of inert gas whether the reaction is carried out at constant volume or constant pressure. So the correct answer is first option. Question number 32. A mixture of weak acid and the salt of the same acid with a strong base is known as buffer solution. For example, a mixture of weak acid, acetic acid, and it's salt with a strong base like sodium hydroxide. This mixture acts as a buffer. This is a fact, yes. Reason: buffer solution shows very small change in pH by addition of strong acid or strong base. This is also a true statement, but this statement does not explain the first statement. So the correct answer is second option. Both A and R are true, but R is not the correct explanation of A. Answer is second option. Question number 33. Solubility of AgI in water decreases in presence of Ki. Solubility of AgI decreases in presence of Ki. Reason: common ion effect decreases the solubility of AgI in Ki. This is a fact actually. AgI is a sparingly soluble salt, whereas Ki is a soluble substance. This is soluble substance, this is sparingly soluble substance. And they have a common ion. The common ion is iodide. So, dissolution of silver iodide in potassium iodide will be less due to common ion effect. So the correct answer is first option. Both A and R are true, but R is not the correct explanation of A. Question number 34. We have to match with the nature of solution. Sodium sulfate is a salt of strong acid and strong base. It's a salt of strong acid and strong base. So its aqueous solution will be neutral. So A should be matched with 3. Neutral solution. Therefore neutral. B. Sodium acetate, it's a salt plus acetic acid. We know that this mixture behaves as acidic buffer. It's an acidic buffer. Yes, it's an acidic buffer. So B should be matched with fourth option, acidic due to buffer action. AlCl3. AlCl3 is a salt of strong acid and weak base. What is the weak base? Aluminium hydroxide, AlOH taken thrice. It's a salt of strong acid and weak base. Therefore, its aqueous solution will be acidic. Acidic due to hydrolysis of Al3+. Al3+ undergoes hydrolysis. So, because of hydrolysis of Al3+, AlCl3 is acidic. Then aqueous solution of sodium acetate. Aqueous solution of sodium acetate. This is a salt of weak acid and strong base. Its aqueous solution will be alkaline. Its aqueous solution will be alkaline due to anionic hydrolysis. Alkaline due to anionic hydrolysis. So this should be matched with the second option, basic solution. So the correct answer is third option. Reactions, question number 35. We have some reactions in the list 1 and we need to match them with the relationship between Kp and Kc. Try remembering this. Kp equals to Kc into RT power delta N, where delta N is number of moles of gaseous product minus number of moles of gaseous reactants. So it's just a matter of checking delta N in each case. Look at this A. The reaction is 2NH3 reversible arrows N2 plus 3H2. For this reaction, delta N is 2. So you need to substitute 2 over here. Then look at next reaction B, PCl5 gives rise to PCl3 plus Cl2. Delta N for this reaction is 1. The next reaction C, Fe is solid. We need to neglect solids. F is solid plus 4H2O gas, reversible arrows. You have Fe3O4 solid plus H2 gas, 4H2 gas. For this reaction, let's find out delta N. This is 4 moles. We need to neglect this, and this is also 4 moles. So, and we need to neglect this because this is a solid. So delta N is equal to 0. And you know, when delta N is 0, then Kp will be equal to Kc. The last one, D. It is 2SO2 plus O2 gives rise to 2SO3. You have 3 moles of reactants and 2 moles of product, so delta N is -1. So putting all these values in this relationship, Kp equals to Kc into RT power delta N, we get the answer. So the correct answer is second option. Question number 36. In the list 1 we have type of salt, and in the list 2 we have examples. Let's try to match this. First of all, let me tell you about Ca3PO4. Ca3PO4 taken twice. This is a salt of calcium hydroxide and H3PO4. For your information, this is strong base and this is a weak acid. Next one is NaNO3. This is a salt of NaOH, a strong base, and HNO3. This is a strong acid, this is a strong base. See, it's just a matter of giving appropriate number of OH to cation and appropriate number of H to anion and get corresponding acid or base. Number 3 in the list is CuSO4. This is a salt of cupric hydroxide and sulfuric acid. Sulfuric acid is a strong acid, cupric hydroxide is a weak base. Then the last one, KCN. KCN is a salt of KOH, which is a strong base, and HCN, which is a weak acid. So if you tally, you get the correct answer, fourth option. Which of the following compound is not a Lewis acid? Remember, Lewis acid is a species which can accept a lone pair of electrons. To accept a lone pair of electron, a Lewis acid should have a vacant orbital. CCl4 does not have a vacant orbital on carbon. BF3 has a vacant orbital. AlCl3 has a vacant orbital. SnCl4 has vacant d orbital and it is capable of expanding its valency beyond octet. So the correct answer is CCl4. Question number 37. CCl4 is not a Lewis acid as it does not contain vacant orbital. No vacant orbital is present, therefore it does not act as Lewis acid. So the correct answer is first option. Question number 38. When equal volumes of the following solutions are mixed, precipitation of AgCl will occur only with, see, Ksp of AgCl is given, it is 1.8 into 10 raised to minus 8. See, precipitation can take place for precipitation to take place, QSP ionic product should exceed KSP. This is possible only with first option, 10 raised to minus 4 m Ag plus concentration, and Cl minus is 10 raised to minus 4. Now QSP equals to, when you mix these two solutions in equal volumes, the concentration of both the substances will become half, because when you mix them in equal volumes, the total volume becomes 2V. So 10 raised to minus 4 by 2 into 10 raised to minus 4 by 2. This comes to 5 into 10 raised to minus 5. This is also 5 into 10. So that comes to 25 into 10 raised to minus 10, or 2.5 into 10 raised to minus 9. This is QSP value, which is greater than KSP value. Sorry, it is minus 10 in the question. So QSP value is greater than KSP value, therefore precipitation takes place. So the correct answer is first option. In a similar manner, you can try for second, third and fourth option. You will find that the QSP value will be always less than the KSP value, so precipitation will not take place in the remaining 3 cases. Answer is first option. Question number 39. The pH of 0.1 molar acetic acid, if K is 1.8 into 10 raised to minus 5 is. Look at the formula For a weak acid, the formula is like this: pH equals to half into pKa minus log C. This is the formula used to calculate pH of a weak acid. Now, C is given as 0.1, so log C will be equal to -1. K is given as 1.8 into 10 raised to -5, so pKa will be very close to 4.7. So if you put all these values, these two values pK and log C, you get the answer pH equals to 2.87. So the answer is fourth option. Question number 40. In the dissociation of bicarbonate and the conjugate base involved is dissociation of bicarbonate. You know, bicarbonate is HCO3 minus. When it dissociates, it becomes carbonate plus H plus. So this is related to this as conjugate base. So the correct answer is third option. The acid and conjugate base differ by 1 proton. So this is the conjugate base, this is the acid. Third option. Question number 41. The conjugate acid and conjugate base of HSO4 minus respectively are. See, HSO4 minus, if it picks up proton, it will transform into its conjugate acid. So conjugate acid of HSO4 minus is H2SO4. And if HSO4 minus loses a proton, it's an amphiprotic species. It is an amphiprotic species. It is capable of losing proton as well as gaining proton. When it loses proton, it transforms into conjugate base. When it gains proton, it transforms into conjugate acid. So this becomes SO4 2 minus plus H plus. So SO4 2 minus is a conjugate base. H2SO4 is a conjugate acid of HSO4 minus. So the correct answer is third option. Question number 42. On increasing of temperature, the equilibrium constant of exothermic and endothermic reactions respectively. First option increases and decreases, second option decreases and increases, third option increases and increases, fourth option decreases and decreases. Remember, if the forward reaction is exothermic, then increase in temperature decreases equilibrium constant. If forward reaction is endothermic, then increase in temperature increases equilibrium constant. So the correct answer is decreases and increases. Decreases for exothermic reaction and increases for endothermic reaction. Answer is second option. Question number 43. If the solubility product of the salt represented by A2X3 is 1.1 into 10 raised to minus 23, the solubility of A2X3 in moles per liter is, look, A2X3 when it dissociates, it gives 2A3 plus 3X2 minus. When it dissolves, this becomes 2S and this will be 3S. If S is solubility, then this will be 2S and this will be 3S. So Ksp equals to concentration of A3 plus square into concentration of X2 minus Q. So it comes to 2S whole square into 3S whole cube. If you put the values are 1.1 into 10 raised to minus 23 is equal to 108 S power 5. So S equals to fifth root of 1.1 into 10 raised to minus 23 divided by 108. This comes to very close to 10 raised to minus 5 M. M stands for moles per liter. So the correct answer is fourth option. Question number 44. If the pH of 0.1 molar weak monoprotic acid is 4, the values of H plus and K respectively are. See, the pH is given as 4, concentration as 0.1. The formula we are going to use is pH equals to half into pK minus log C. So pH is 4 equal to half pK. Log C is -1, so minus of minus is +1. So pK equals to 7, therefore Ka equals to 10 raised to -7. And the concentration of H plus is equal to 10 raised to minus pH. This is equal to 10 raised to -4. So the correct answer is third option. Question number 45. The number of grams of sodium hydroxide present in 100 ml of sodium hydroxide solution of pH 10 is. See, pH equals to 10 corresponds to pOH 4. That means OH minus concentration is 10 raised to -4. This we can take it as molarity of sodium hydroxide, because sodium hydroxide is a strong base, or M equals to 10 raised to -4. We have this formula, M equals to weight by gram molecular weight into 1000 by volume. So M can be replaced by 10 raised to -4. Weight we need to find out. Gram molar mass of sodium hydroxide is 40. This is equal to 1000 by 100. 100 is the volume of the solution given. So this comes to 10, and then the correct answer is, this comes to 4. 4 into 10 raised to -4 grams. This is the weight of sodium hydroxide that should be dissolved in 100 ml solution, so that the solution will have a pH 10. So the correct answer is third option. With this, we have come to an end of discussion on some important questions on chemical equilibrium. We have discussed both questions on chemical and ionic equilibrium under this section. Thank you for listening. Thank you very much.